modules that would help students understand the basics of business systems by um, by making them build certain products. So if you look over here, this is essentially a compound magic clock, right? The idea of this clock is to build something that counts from 0 all the way to 60, right? So I'm not sort of telling the students as to what a counter is, what a clock is. Right? What I'm giving them is a compensator, which is to say that you need to develop something that performs the job of a digital clock. Now, what they have to think about is how do I build something that can count from, let's say, 0 to 9 or 0 to 99. Then they have to think about, well, this something has to reset itself at seconds, which is 59. Then they have to think about, oh, when it resets at 59, how do I pass that information onto something else that counts minutes, right? So after 59 is done, then the minute should be implemented. Once the minutes reach 60, then the hours can be right? So the good for example, if you look over here, this is essentially an self-contained 8-bit CPU. It's a very simple machine that that does very simple thing of printing the Fibonacci series, right? So all it does, it prints the Fibonacci series. It's supposedly a general purpose computer, but it has been programmed to print the Fibonacci series. But it has been developed from basic gates by hand on breadboards by connecting wires together. And in the process of doing that, we sort of think about everything that we have to think about for building a basic CPU, which is what is the program count, what is the file, what is an ALU unit, what is an instruction, how is it being encoded. All of that is built using these right? So the idea is we give proper statements like this. This is a basic virtual calculator. You give it inputs. You give it 4 bits worth of magnitude, 1 bit worth of sign. So there are 2 inputs. I could sort of give it 2 inputs in binary. So when it's turned up, it's a 1. So you see this input is a 1, this input is a 1. And the sum of these two is 0. If I make one of these things as negative by turning this switch on, it is a sum of 1 and minus 1 and the output is 0, right? So the problem statement is very simple. I want to give you something which is signed and valuable in binary format, and now you have to build a working calculator. And what do you have to do as a process of doing that is something that they learn in the system. So there's a whole bunch of these things that are being learned there.
Yeah.
Right? And there's an entire course that we're developing around this that we will eventually sort of take public.
So you are mentioning you are developing a course out of it, right? Now to do this course, apart from theory, you also need to make sure these materials or the
Correct.
equipments
Correct.
should be available.
Correct.
So from where they can buy?
Yes. So we are also developing an entire kit, right? So it is right now we have developed this course as an 8-module sort of course. Each of these modules they will build something, right? So in one module they will just clocks and counters. In the other module they will just they'll understand the notion of clocks and counters. So the other thing they build CDCs. In the other thing they will build a calculator. Each one of those modules will come with a small kit, which will have all the components, the breadboards, the basic gates, the wires, everything else. For example, you also have to display the output, right? So you have to understand how input output works, how an 7-segment display sort of works, right? So we'll have to also sort of teach them the basics of that. But each module will come with a small kit, self-contained kit, and instructions about how to sort of build these various things. And in the process of building those things is how we will build it.
So a person will get the kit only when the person will enroll for the course, or they can also buy the kit, let's say, for do yourself.
So the idea is to do, right? It is my idea is that it is most effective. This entire thing is most effective if you do this as a part of a course, because that brings in a certain amount of rigor and also brings in a certain amount of logical progression of how you learn various things, right? But if somebody is motivated enough and they get the kit, there is no stopping them from building this thing on writing, right? So if you have all the components that are needed to build a calculator or a compact digital clock, you could potentially do this by buying the standard.
Okay, so it will be available in both the mode. Now, considering the economics of India and the per capita income and in the even the buying capacity, what is the price, or what are the price you
That's a good point, right? So each one of these individual components is not very expensive. The breadboard on this thing is the most expensive part, which is roughly 200 rupees, the large one. Right? The individual basic gates ICs are relatively cheap. The LCD displays are relatively cheap. The wires are cheap, right? So if I give them the schematic of, this is how you build a calculator based on these basic circuits. There is nothing stopping them from going out in the market and getting all these components and making it themselves. And I don't think the BOM of this entire thing is going to be extremely costly, right? So it is not something which is outside the purchasing power of.
So what's the like you mentioned bomb, right? So considering bill of material, let's say for one equipment, what is the maximum bill of material?
We haven't sort of calculated that yet because right now we're in the process of just building these things, right? So we purchase a lot of stuff and kind of build all of these things. But how much would sort of just making a clock or making a calculator take? It's a good question. I haven't calculated it.
Okay.
But it will be good.
2000. Thanks.